Lesson 8.4, rate of change, and 8.5, constant rate of change and direct variation, are very closely related. That's why we're doing them together. A rate of change is the rate that describes how one quantity changes in relation to another. So some of the things that we've talked about earlier in like unit rate and things, it's very similar to that. So let's look at this first example, and we'll look at two different quantities and see how they're related. So we're looking at the pages read on the y-axis. So we're comparing the pages read to the time in minutes. So kind of like unit rate, how much per minute and things like that. It's very similar. Again, they're calling it something different, and next week we'll even call it a different name. I know it sounds strange, but it's all of the things are related, and they're all called a different name. So the rate of change, the way that you tell what it is, you find the change in the pages read. Okay, now remember that the time, the minutes, is the x-axis, and the pages read is the y-axis. And what we have to look at would be these two ordered pair right here. Okay, so this one up here, if it's got 24 first in the x place, that means 24 what? If the x place, that means 24 what? Logan?
24
minutes, because that's the x place. And then the 8 in that ordered pair means what, Logan?
seconds.
No, what's the y stand for? Pages read. So in 24 minutes, they can read 8 pages. But when it says the change right here, when it says the change in pages read, you've got to compare the two ordered pairs. So I'm going to do this. The change in pages read, well, in the one at the top, there were 8, minus down here at the very beginning, the y value is 0. That's how we'll figure out the change. So it went from 0 pages read to 8 pages read. We'll figure out the change. I'm thinking you could figure out that means 8. Over the change in time. So since we dealt with this ordered pair at the top first, the change in time, 24 minutes to do the 8 minus 0 minutes, obviously, to do the 0. So when you do this, 8 over 24, and does that reduce?
Yes.
Yes, it reduces to what?
1/3.
1/3. So the rate of change for this particular person would be this: 1/3 page per minute. Okay, this person read 1/3 page per minute. We're figuring out their rate. Okay, so I'm going to tell you very soon you're going to be doing something called slope. I know you've seen it before, done it before. That's what we're heading towards Monday. This is what these are all related to. These are all related to slope or rate of change. They are exactly the same thing. It just depends on what you're referring to, which word, which vocabulary you use. Okay, let's look and see what else it's looking at here. The rate of change. This time it's given to us in a table, and it's saying the change in temperature. Well, the temperature is down here, and it's over the change in time, which is hours. It's up here. Okay, so if I had to pick out two temperatures, let's just do these first two. Let's just do these first two. So the change in temperature, so from the second point, what temperature is it? The second point, what temperature is it? How many degrees Celsius? 2. And what is the temperature in the second or I'm sorry, the first point, 0. And then the change in time, you go back to that second point, it was 1 hour minus back to 0. You kind of match up the points when you're doing this, okay? You usually start with the second point minus the first point on the top, and then you do the second point minus the first point on the bottom. So 2 over 1. So it would be 2 degrees Celsius per hour is how you would do that. That's the rate of change. It goes up 2 degrees Celsius per hour. Questions on that? Okay, let's see what's next here. Constant rates of change. Okay, constant rates of change is what we really study, where the relationships of the two different things, just like the temperature and the time and the reading pages and time, they have a straight line graph. They make linear relationships, okay? That's why we study them, and that's why they're in this chapter. Everything in this chapter is dealing with linear relationships and lines. It has a constant rate of change. I'm going to tell you ahead, Monday when we look at slope, that's what this is. Constant rate of change, we are heading towards slope, the slope of a line. They call it rate of change when you're talking about real life kind of things. So it's the rate of change between two different things. And then it talks about proportional versus non-proportional. So if it is a constant rate of change, it is proportional. Okay, so let's look at this example with the height of a tomato plant. The height of a tomato plant. So we are talking about a garden, the height of a tomato plant. So Gina recorded the height of a tomato plant in her garden. Find the constant rate of change for the plant's growth in the graph shown. Describe what the rate means, then determine whether there is a proportional linear relationship between the plant and the time. So basically, you could do this on the I-STEP, you could do this on Acuity. You're definitely going to do it next week. They're going to give you a graph, and you need to find what they're going to call the rate of change. Honestly, you're finding the slope. So you really want to find 2 points that are on corners. And when I say that, I mean where you can actually tell what it is. So they picked this. They picked 3, 5 because it was on that corner right there. And then they picked 7, 15. You can't pick some random point out in the middle because you don't know exactly what it is. And your stuff would be off. So you want to go and find points where it hits corners. If it doesn't hit corners, then you're going to have trouble. But this one, luckily, it does. So they have written the points down. Now remember, weeks are X, height is Y. Okay, so the first point there is 3, 5, and the second point was 7, 15. And the 3, 5 means in 3 weeks it's 5 inches tall. The 7, 15 means in 7 weeks it's 15 inches tall. So we're going to find the rate of change between those 2 points. So the change in height, what's the height now, the X or the Y? The Y. So you do the first and the second point. I'm going to say this one's the first and this one's the second one. What's the Y in the second point? 15. Okay. Minus, what's the Y in the first point? 5. Okay, and then we want change in time. So that's the weeks. What's the time or the weeks in the second point? 7 minus the time or weeks in the first point? 3. And then you actually subtract, and you get 15 minus 5 is 10, over 7 minus 3 is 4. That reduces to 5 halves. Anybody know what that is as some number that we could actually realize what it means? What would that number really mean? 5 halves is the same as what, Stephen?
Wouldn't that be the same as 2.5 over 1?
It would, okay, let's just make it 2.5. All right, which means literally 2.5 inches per week. Okay, 2.5 inches per week. Okay, so,
I have a feeling this is going to go over 15 minutes.
what's that?
I have a feeling this is going to go over 15 minutes.
Well, I'm going to stop it at 15 minutes. So, here's how you tell if it's proportional or not. So we found the rate of change, 2.5 on average, 2.5 inches per week. But we're going to tell if it's proportional or not by taking points and seeing if they all reduce to the same amount. Now, the first point we used was 5 inches in 3 weeks. What's 5 over 3 reduced to? Anybody know? What decimal would 5 over 3 be?
1.2?
Close. It's like 1 2/3. So 1.67. Now, if they all reduce to 1.67, we're good. The 10-inch mark, what week does the 10-inch mark hit? You see the 10 inches? Go across. Where does it hit? How many weeks? 5. So 10 over 5 is how much? What would that reduce to?
5 over 1, 2.
10 divided by 5, that'd be 2 inches per week. The first one was 1.67, and then the 15 inches hit how many? 7. And that actually is 2.14 inches per week. So since the ratios are not equal, the relationship is not proportional.
Is that like an equal sign with a line through it?
Yes, an equal sign with a line. The ratios are not equal. Put an equal sign with a slash through it. So the linear relationship is not proportional. If all of those reduce to the same exact thing, then it would be proportional. Direct variation is when you have the two quantities and their ratio is constant. It's the same all the way through. It's called direct variation. Generally, you see this equation, y equals some number times x, and that some number is actually the constant of variation. It's what relates x and y. So this example with the scuba diver is a direct variation relationship, okay, and you can make predictions then based on that information. So we're going to use this equation, y equals kx, and we're going to pick out a point, and it looks like over here they've picked one. We're going to pick out this one, and we're going to figure out that constant k. So what you do is you've got a y equals k times x. You plug in 17.8 for y. You leave the k because you don't know it. And the x you would use would be times 40. So when you have a problem like this, how do you solve for k? When it's 40k, how do you get k alone? Divide both sides by 40. And when you do that, the constant of variation, I'm going to kind of cheat because I know what it is, 0.445. You could easily solve that and figure it out. So what that is telling me is my constant of variation, how these two things are related, the water pressure and the depth that the scuba diver is at, is related by that value. So y equals 0.445 x. Okay, so the water pressure, y, is dependent upon the depth, x. Predict what the water pressure would be at 28 feet. So the feet is the x. So when you do that, once you get this equation, you can take 0.445 and plug in any depth in this case 28, and figure out what the water pressure would be. In this case, it would be Y equals 12.46, and that is pounds per inches cubed. I'm sorry, squared.